Hi students, today we can discuss about eddy current or Foucault current. In today's class, I will explain to you about eddy current and its applications. The main applications of eddy current are induction motor, speedometer of vehicles, induction furnace, induction cooker, and power brake system. And also some of the undesirable effects of eddy current, that is energy loss in transformer and energy loss in generator as well as electric motor. Also, I will show you the working of two devices, that is induction cooker as well as power brake system. Eddy current, it was discovered by Foucault, the scientist Foucault, so it is also called Foucault current. The basic principle of eddy current is electromagnetic induction. It was discovered by Faraday. We have seen in previous class electromagnetic induction. In electromagnetic induction, if you move a magnet in a coil, it is a coil made up of thin insulated copper wire. When we move the magnet inside the coil, it will produce a variation, change in magnetic field. So it will induce a current, and because of that induced current, the LED is glowing. So depending on the direction of magnetic field change, it induces current, so the different LEDs are glowing. And here we are producing a change in magnetic field associated with a coil, thin wire of copper, and it is inducing current in the copper coil. In case of eddy current, instead of thin wire of copper, we have to use a large metal block. And Foucault observed that when a large metal block, this one is a large metal block, when it is kept in a varying magnetic field. So for producing varying magnetic field, here we have two electromagnets. They are called field magnets, and these two electromagnets are provided with the alternating current. When alternating current flows through this electromagnet, it produces a change in varying magnetic field. And due to that variation of magnetic field, it induces current in the metal block. And you know that current always seeks low resistance path. It wants to flow through area where there is less resistance. So since it is a large block of metal, eddy current will be induced in the metal block in many closed loops. So it will form just like eddy formed in water. So many circular loop of current will be formed in the metal block. And because of that current formed in the metal block, we know that resistance of a conductor is inversely proportional to area cross section. Since it is a large metal block and it has very large area cross section, its resistance will be very less. And also we know that according to Ohm's law equation, I equal to V divided by R. That is, if resistance is less, current will be very high. Again, according to Joule's equation, H equals to I square RT. Means if the current is high, by square of that, heat energy will be produced. So, as a total effect of this, since it is a large metal block with a large area of cross section, resistance is very less. And since resistance is very less, current will be very high. As current is very high, by square of that, heat energy will be produced. It means a large amount of heat energy will be produced in the block of metal due to eddy current. And that heat energy we can make use of many practical appliances. So here we will see the applications of eddy current, mainly induction motor, speedometer, induction furnace, induction cooker, and power brake system. Induction motor, an example for induction motor is our ceiling fan. The normal ceiling fan that we use in our home, it is not a normal motor, it is an induction motor. In that induction motor, we are providing a field magnet by using electromagnets. And electromagnets are provided with alternating current, and in between that field magnets, we are keeping the metal disc. A large metal disc is kept between the electromagnets. So this is the large metal disc kept between the electromagnet. And since this heavy metal disc is kept between the varying magnetic field. It will produce eddy current, loop of current inside this metal disc. And due to the eddy current flowing through the metal disc, it will experience a torque in the external magnetic field. And due to that torque experience, it will start rotation. And on this disc, we are connecting the blades of the fan. So when we connect the blades of the fan like this, the disc when it rotates, the blades also will rotate and it will give the wind when it rotates. So this is the ceiling fan. Its working is based on the eddy current produced in the metallic disc, which is kept between two electromagnets, which provides a varying magnetic field. Another application is speedometer. Speedometer of our vehicles. Speedometer of our vehicle is again based on eddy current. In speedometer, it consists of an aluminum cylinder. It is kept between two permanent magnets, a north pole and another south pole. This aluminum cylinder is fixed with a needle, and that needle will show the rotation, it will show the speed of the vehicle on the dial. At the bottom of the aluminum cylinder is also fixed with a cable, and this cable is connected to the tires of the vehicle. So when the tire rotates, the cable will spin. Due to the spinning of the cable, aluminum drum rotates between the magnets. When aluminum drum rotates between the magnet, due to the change in magnetic field of the aluminum drum, it will induce eddy current inside the aluminum drum. Eddy current is formed inside the aluminum drum due to the current flowing through the conductor, and it is placed in an external magnetic field. It will experience a torque. Because of that torque, aluminum drum will rotate. When the aluminum drum rotates, the needle also will rotate on the dial. It shows the speed of the vehicle. So if the vehicle is moving with more speed, the cable will be spinning with more speed, so the aluminum drum also rotate very fast. Means the variation or change in magnetic field will be more, and more eddy current will be induced, so it will experience more force, more torque, so it will rotate more distance, more angle. So we can see that the speed of the vehicle can be proportionally obtained from the angle of rotation of the needle that is in turn connected to the aluminum drum. So speedometer of a vehicle is also working according to the principle of electromagnetic induction. Another one is induction furnace and induction cooker. Both of these are working according to the same principle. An induction cooker, nowadays it is very common in our kitchen. Induction cooker, it consists of a coil which provides highly varying magnetic field, and a vessel will be kept above that coil. So in induction cooker, we can see at the center of that there will be a copper coil like this, and alternating current will be passed through the coil, and the vessel will be kept just above this one. So when alternating current passes through this coil, it produces a varying magnetic field, and due to that magnetic field variation, eddy current will be induced in the vessel itself, so the vessel will get heated up. And that principle is used both in induction cooker and induction furnace. In induction furnace, large metal container will be provided with the coil through which alternating current will be passed. When alternating current is passed, it will produce change in magnetic field that will induce eddy current in the container vessel itself, so the vessel will get heated up. And that heat energy we can make use of melting the steel, iron like things in induction furnace. And the last one is power brake system. In power brake system, we can make use of again the principle of eddy current, and it is used usually in electric train. In power brake system, usually in electric train, electromagnet will be kept against the rail at the bottom of the engine. So when brake is applied, the electromagnet of the power brake will be activated, and it will induce eddy current in the rail, and that will give a torque to the wheels opposite to the rotation, and it will stop the train. I will show you that working of induction cooker as well as power brake in the working model. Before that, there are some undesirable effects also for eddy current. These undesirable effects are mainly energy loss in transformer and also energy loss in generator and electric motor. Energy loss in transformer is basically because of the eddy current. This is a transformer, a step-down transformer. It is used for reducing the voltage of alternating current. It consists of two coils, primary coil and secondary coil of copper wire, and it is wound on a soft iron core. This part is soft iron core, and you can see here this soft iron core, instead of using a thick metal block, we have used here many thin sheets of soft iron, and one piece is removed from that is this one. It is a very thin, and many thin sheets like this are sticking together, and it is called a laminated soft iron core. This laminated soft iron core is used to reduce eddy current. Because of that, we can reduce the heat energy produced in the metal core due to the formation of eddy current. So instead of using a large, thick metal block for core of the transformer, instead of that, we are making it in thin sheets like this, and each sheet will be separated by an insulator. So these two thin sheets nearby are not in direct contact. In between them, we are keeping an insulator to avoid the electric flow. So when the thickness is very less, area cross section is very less, resistance will be very high. So R again inversely proportional to area cross section. Since area cross section is less, resistance will be very high. When resistance is very high, its eddy current produced in this will be very less. So we can minimize the eddy current, and thereby we can minimize the heat energy produced in the core of the device. And also we can see the same problem of heat loss is there in the core of generator and electric motor. Here you can see the core of a motor. Here in this motor, instead of using a large metal core, it is using, you can see thin sheets of soft iron is sticking together. It is called laminated core. Laminated core is used to avoid eddy current induced in the core, and it can reduce the heat loss in the core of the generator as well as electric motor. Now we can see in detail the working of induction cooker, which is very common in our kitchen, and also the power brake system. Okay, this is an induction cooker which we commonly use in our kitchen. If I open this outer cover of this induction cooker, you can see inside the main working part of this cooker is a coil. This is the copper coil which provides a varying magnetic field, and we are giving the electrical supply through these two wires. So when an alternating current is passed through this coil, it produces a varying magnetic field. A high variation of magnetic field is created in this area, and we have to keep the vessel just above that on this circle. And the vessel kept on the surface, it should be a metallic one. So eddy current will be induced in the metallic vessel itself, and it will get heated up, and that heat energy we can make use for cooking the food. So the main working part of the induction cooker is the coil, which provides a varying magnetic field. Another part of this coil is a fan, which is used for cooling this coil, and also there are some switches for adjusting the heat energy, adjusting the temperature of the vessel, which is produced due to the variation in magnetic field. So this induction cooker, it is working according to the principle of eddy current, which is produced due to the variation of magnetic field in the metallic vessel itself. Another device we have here is an electric power brake system. This electric power brake system consists of an aluminum drum. It is connected to a motor, and there is a strong magnet here. It is connected to the pedal of the brake system. So if I apply force here, the brake magnet will lift up, and when it comes closer to the aluminum drum, and if the aluminum drum is rotating, it will produce a change in magnetic field. Because of that, eddy current will be induced in this. Due to that eddy current, it will experience a torque in the opposite direction of rotation, and because of that, it will try to stop. I will show you that working. Okay, when a current is passed through the motor, the aluminum drum is rotating with a very high speed. And if I bring this magnet near to the aluminum drum, you can see the speed of rotation gradually decreasing. And usually you know that aluminum will not be attracted by a magnet. But here the force is due to the eddy current. When the magnet is kept very close to the aluminum disc, okay, it is inducing eddy current in that, and due to that eddy current, it will experience a torque in the opposite direction of rotation, and it will try to stop the aluminum disc. If I remove the magnet, again the speed increases. If I bring it closer, it will reduce the speed. So even we can stop the rotation of the disc by adjusting the strength of the magnet. So it mainly consists of, you can see the construction here. It is made by using wooden things here, okay, and on this brake pedal, this is the brake pedal, okay. The brake pedal, if you apply force, the magnet will get lifted up. When it comes closer to the aluminum disc, it will stop it because of the eddy current produced inside that. So it is a easy working model that you can make for any exhibition, which uses the principle of eddy current and in power brake system. And the advantage of this power brake system is that here the disc and magnet are not coming in direct contact, so that there is no problem of friction or wear and tear. No need to change the brake shoe frequently in the case of power brake system, because there is no role of friction in this case, and the disc is stopped only because of the opposite torque experienced due to the eddy current flowing through this. Okay, thank you for watching this video.